Okay, so these notes are over proportional and non-proportional relationships. This is actually one of the simplest things that we do in 8th grade math, in my opinion, because you're looking for one specific thing. No matter if you're looking at equations, word problems, graphs, or tables, the difference between them is always constant. Okay, so a proportional relationship are two quantities that have a constant ratio. So that means the only thing changing in these equations, or in these equations from one variable to the next, is that one ratio. Whatever your slope is, you're multiplying that by one of your variables to get the other. Okay, so anything that is proportional, you can write as y equals kx. Okay, and here, this k is our slope. I know we also use m as slope. There are a variety of ways slope can be represented in word form and referred to as. So we'll be talking about and making a anchor chart for the class of all the different ways we can look at slope. But anything that is non-proportional, we write as y equals mx plus b. Now this is the one we're more used to seeing. We see this one a lot. And here, this one has a b, whereas this one doesn't. So if you see in all of these equations, y equals 2x, y equals negative x, y equals negative 1/2 x, there is nothing we're adding out here. Whereas here, there's something added here. This one would just be a straight line up and down, or left and right, sorry. And this one is actually a shape we don't look at really in 8th grade. So for us, non-proportional relationships are going to be anything that has a b. Oh, sorry, this one says it cannot be written as, so I'm going to scratch not out. But basically, you have a y-intercept, so you can't write it like this. If it has a b, we know that that's our y-intercept. So anything that crosses the origin or crosses the y-axis anywhere other than the origin, that is non-proportional. So if you look down here at these graphs, you could see that in the difference here. This graph, it's a line, it's linear, and it crosses up here. It is non-proportional. This graph is a line, it's linear, and it crosses right at the axis, or at the origin. So any proportional graph is a line that goes through the origin. And if it is non-proportional, it either does not go through the origin, it hits somewhere else on the axis, or it's not a line. Okay, so if there's any kind of squiggly, like number 2 down here, this is not a straight line. Even though it does touch at the origin, it's not a straight line. So this one would be non-proportional. Okay, when you're looking at tables, we're going to do the same thing we would just to find a regular equation. So if it is a proportional table, it has a constant ratio. That constant ratio is the only thing that changes. It doesn't have a starting point or a flat fee or anything like that, so there is no b. Okay, so for tables, we go into stat edit, and we put in our x values. So I have -1, enter, 0, enter, and we move over to L2 for our y values, -3 and 0. We go back to stat, calculate 4. And this equation gives me, let's write it like this. A, which is what our calculator gives us for slope, and B is 0. So if we were to write this as an equation, we would write y equals 3x. We don't write the plus 0, and that means that it goes through the origin, so it is proportional. Non-proportional relationships do not have a constant ratio. So yes, they do have a slope, but they also have some kind of y-intercept that changes. So here, if you look at your x value, -1, if I take it and multiply by 3, that's going to give me -3. 0 times 3, 0. 1 times 3, 3. 2 times 3 is 6. So let's go get this equation, and I can show you the difference. We're going to go in and put them in our stat edit, and then go back to stat calc 4. And this one gives me an a of 1 and a b of 2. So even though my slope is 1, if I took every x value and multiplied it by 1, I'm not going to get this number down here. 2 times 1 is 2, not 4. 4 times 1 is 4, not 6. So That's why it does not have a constant ratio. There's going to be an additional piece that changes every time, and that is our plus 2 right here. So to write this in an equation, we would have y equals x, because remember, we don't have to write the 1 in front of an x, plus 2. So whatever this number is times itself plus 2, and that's what makes it non-proportional. So as far as situations and word problems, verbal descriptions, whatever you want to call it goes, they're also going to have a difference that you can see with all the keywords we've talked about so far this year. So proportional relationships only have a rate. Okay, so you're going to see with our rate, that's our slope or our K or whatever you want to say. And remember, the 3 words we look for are per, each, or every. When we see that in a word problem, we know that that's what's going to get my X. So we know that Erin charges $12 per hour. So to write this as an equation, I would say that the money she earns is equal to $12 times every hour she works. So there is no y-intercept. She does not charge you for gas to drive to your house or for meals that she cooks. It's just $12 per hour. A non-proportional relationship, it does still have a rate, but it also has some kind of fee or starting point. And that fee is represented as our y-intercept. So for this equation, we see that Angela charges a $50 deposit plus $30 per hour for her accounting services. So I know that my 30 is going to get my X, but that's not all I have to pay Angela. I'll also have to pay her this $50 deposit. So that $50 deposit here is what makes Angela's situation non-proportional. So basically, anything that has a y-intercept is non-proportional. Anything that does not, which is 0, if it doesn't, it's 0, that's where it crosses, that would be proportional. So looking down at our examples, if we looked at this first one here, we have no y-intercept out here. I only have my slope, so this one would be proportional. Under it here, it says Bob delivers flowers for a $10 fee and $3 per flower. So I know that the X goes with 3, but I also have to pay him $10 to deliver them. So this one would be non-proportional. On 5 here, I do have my slope, my K, my M, my constant of variation, whatever you want to call it. But I also have a y-intercept, which makes this one non-proportional. Here on 6, I have a straight line that goes through the origin, so this one is proportional. And on 3, I'd have to figure it out in my stat edit. I've got 3 and 6, and 1 and 2, stat calc 4, and it gives me an equation of A is 1/3 and B is 0. So that means that this equation here, because this B equals 0, is proportional.